Hi, I'm George Magklaras. What I'm going to do in this video is to take you through a walkthrough of System D. System D is one of the largest changes that you're going to feel in the day-to-day operation of a RHEL 7 system. Although controversial for some, it's something that replaces the init system inherited by the System V and the BSD family of operating systems. And it's a beast in itself in that it can do a number of tasks apart from starting, stopping, or enabling and disabling services, including parallel startup of system services at boot. So the boot time is substantially reduced. You can have on-demand activation of daemons based on certain conditions. You can also use systemd, the systemd daemon to take system state snapshots, and a number of different things like the control of SIG groups on which systemd is actually based. But as I said, essentially this is a basic walkthrough for actually familiarizing you in terms of starting and stopping certain system services. So what we have here are two windows. On the left, the black background window is a traditional 6.5 init system V based system, which is RHEL 6.5. And on the right here we have the new system MIPO, and of course it's the latest kernel at the time of taking this screencast. Okay, so let's get started. Let's go to the traditional or the RHEL 6 system, init-based system. You obviously should be now aware of, or you know your commands. So a check config list, and if we pipe that to more, that will give you a list of all services in the system and whether they are available, they're actually enabled or not on different run levels. We have, of course, the concept of run levels, so I bet that most of you have touched your init tab file, and you can see in this particular instance that the server that we are actually logged in here on the left is actually running the default run level 3, which is the full multi-user mode without graphical user interface. And of course, you should also be familiar with the initd directory structure. So here you have some service scripts. All these are scripts that actually start and stop services. And of course, under etc rc run level type .d, you actually have symbolic links to the etc initd directory, like we display here. First the kill scripts and then the startup scripts, with all, of course, the symlinks in under the etc init.d directory. So that's the traditional way of looking at things. That is has actually changed on RHEL 7. Here you have a new friend called systemctl, and of course we can list something that systemd calls units. So actually we don't need the switches here. The unit is the equivalent of, let's say, an init startup or stop script. So it's in essence a config file that encapsulates information about services, listening sockets, state snapshots, but of course we want to actually only list the service type here. So if we type that and press enter, what we see on the left here are all the equivalent services that we saw with the check config command on the left before. So let me do it again. There we go. And of course here you have various information columns. The load column indicates whether the unit file of the service has actually been parsed, like the config file has been parsed and loaded on systemd properly. Active doesn't mean running or stopped. It means whether the process is enabled or disabled, or on or off, as you would see it on the check config command on the left. And of course the state is actually the subcolumn here, whether you have exited processes, running processes, or inactive processes. You don't actually see the services that are not running here, or the inactive services, because you need to pass this switch here. So here we with the previous command, without the -- all, you display only the active services. If you want to list all services, you just also add -- all, and there you go. Here you see services that are dead or inactive, meaning not enabled services. Okay. With reference now to the etc init.d directory, what you have here is actually the etc systemd directory, and under there you have a subdirectory called system. And of course here you have actually the actual files that you want to, the unit files that for the various subcomponents of the systemd service. In contrast to init, the init systemv system or BSD system, the systemd system can actually give you transient services, meaning services that are started asynchronously. So you also have, for example, something that's called the run systemd system subdirectory, and here you will find all these transient processes and services. You also have the user let's have a look, the user lib systemd directory, system lib systemd, and then system. And in fact what you do have here are all the unit files for the different components, and in fact this is, let's say, the equivalent of the etc init directory on an init based system, because most of the other systemd directories actually symlink to the files that you actually see on this particular directory, which is user lib systemd system. Okay, it's worth keeping this, taking note these three directories, because they can be this knowledge can come handy when you troubleshoot problems later on, lower level problems. Okay, so let's see more concrete examples here on the left. Let's say that you want to see the status of your Apache server. So you would do something like service httpd status, and of course you would get something like httpd process, the process ID is running. So you can then I guess do this to see your process, your Apache process running. On RHEL 7 you would do something different. You would invoke, of course, who else systemctl, and you would say status and the process. What you see in this particular case is that yes, there is actually a unit file for the httpd.service. The service itself is loaded, but at the moment is not enabled. So in other words, nobody has actually started the process, the Apache web server, and neither the service has been started. How would we do that? Well, we would type something to, first of all, enable the service. So we could actually say systemctl, the word enable, and then the service that we want to enable. And we could see then that this particular command, which I guess is the equivalent, if I type the equivalent command on a traditional init-based system, that would be, I guess, something like check config levels level 3.5, the two levels that are used in frequently, and then the service, and then on. Okay, and then I would check with check config that this is on by doing something like this: check config list and grep httpd, and then I check that for run levels 3 and run levels 5 the service is on. Well, this is what I've just done here, and then you see that what the system actually does, it creates a symbolic link from this directory, the etc systemd system multi dash user target httpd.service, to this directory. So from the main config to the user lib systemd system httpd.service, this is something that I actually explained in the previous step. Well, is the process running? Well, it's actually enabled, but it's not active yet. So I could just, I guess, do this and then say systemctl start httpd. And if I repeat the status command now, I would actually see that the HTTPD web server has started. So the service is loaded, it is active, it's up and running. It has a certain PID here. Since systemd controls, of course, everything by using control groups, C groups in Linux, I get the relevant C group info here. And then I also get the relevant messages from the actual log, which is something that it doesn't happen, of course, when you do things with a traditional init service command. You will have to manually go into the relevant logs and actually check that the service is started, or whether the service has actually spit up an error in the log. Okay, so that's, I guess, the equivalent of doing the service httpd start command. Okay, service httpd stop and service httpd start. So that's a very basic way of actually enabling and then starting and also stopping a service. So if I want, for example, to stop temporarily the web server process, then I would type systemctl stop, checking again with status that the relevant processes have been of course stopped, and the relevant things in the log file, and then I guess I could just start it again. So there we go. That's a very simple, plain example of how you would use systemctl to enable the service, meaning configure it as on your run level, or target. We're gonna talk about targets in a minute. And then start and stop the service. Right, I'm going to actually clean up a bit here. So let's clear the windows so we have some space to type more. And of course, I talked earlier about targets, and simply targets is the terminology for what you considered before as run level. So we had the default run levels on RHEL 6 system. If you want to see the run levels or targets as administered by systemd, what you can do is do a systemctl, list units, because of course we want to list the available configuration files, but instead of service this time we'll are looking for targets, aka run levels. So if you do that, essentially what you have is a list of the possible run levels, aka targets, on the RHEL 7 word, being here side by side. So for example, you can see some arbitrary things here, but you can see familiar things like the multi-user target, which is, I guess, is the equivalent with run level 3, the old run level 3, the full multi-user mode. And the other target of interest is of course the graphical dot target, which of course is the equivalent of run level 5, which is the X11 or the full multi-user mode with a graphical user interface. Okay, so essentially you can get the default run level of the system by typing this command, systemctl get default, and you will see that the default in this particular case is the target, so the graphical target. So this is would be the equivalent of actually going into it, etc. init tab, and then seeing what's the init default level here. Okay, so one small detail is also the fact that you can actually see all sorts of different targets that are not active by systemd if you add in the command the switch -- all. So good. So how would we actually change the run level or the default target on a system? Well, let's take our system here and do a small demo, the RHEL 7 system. So let's say that I want to actually change from the graphical target to the multi-user target, because for example, I don't want to waste resources. If this is a server system, I would like to actually exclude the graphics display manager. How would I do that? I would actually type systemctl, surprise surprise, and then set default. And this is of course the command, the subcommand of the systemctl that actually changes the default target, aka run level. So then I will type the destination target, which is multi-user dot target, and if I do that, again what the system reports as happening is that it removes the default target, which is of course a sim link to either the graphical target or the multi-user target, and in our case it actually sim links the default dot target to the multi-user target, which leaves of course under userlib systemd system multi-user -user dot target. Okay, so of course you see nothing happening because what we need to do is attempt to reboot the system. So let's go ahead and try and do that. Systemctl reboot. That gets us back to the grub2 screen, and then we'll load the latest kernel. And of course the system has already booted, and then we don't see a graphics display manager anymore. So if we want to reach back to the graphics user environment, we have to start it manually. So let me try and log in again and then do a start X. And there we go. This is where we were before. So let's go back to a terminal. Sudo -i, my password, and then we could actually set the system back to a graphical target. So let's see the target. Yes, it's the graphical target, so we can type set default graphical dot target. So that should restore again the default run level. So let's go into one more time through a reboot process, systemctl reboot, and booting again the latest kernel. And eventually we should see that the system starts again with the graphics display manager enabled. So that's a good indication that we have achieved our tasks to change the default run level using systemd. Well, that's it for now. I hope you enjoyed that, and keep reading the blog.